Hi guys, this is a re-implementation of my virus propagation simulator, but I've re-implemented it in Java using what's called a swing toolkit for the user interface. It's largely so that I could have a better user interface on it. So this is what it looks like now. It looks a bit aesthetically plain compared to the version that was done in a game engine, but it's a better simulation overall. But I'll just show you some of the features. It's about 80% feature comparable with the old version, so it does nearly all of the same things, and it's also got some extra features as well. So I'll just start it off with the default settings. There we go. I'm not sure if I like that flickering when they get infected, but one huge advantage of not using a game engine is that the rendering and the modelling are separate, so you can do things like this. You can just run the model at the maximum speed, and it doesn't in any way affect the outcome of the model to run it at full speed. But for some of the more complex situations, that's useful, because before you just had to sit and allow it to finish at its own speed. Let's just try tweaking this a little bit. Let's change the size of the blobs. They're the actors in the simulation. So we take it down to from 14 to size 7. That's scale the grid as well, but we'll switch the grid off for that small scale, and then take it from 400 blobs. I think that was about the maximum this machine could manage with the old one. Just take it up to 800, and we'll switch off lockdown completely. Well, no, we'll keep it the same. We'll keep it at 75% of the people in lockdown. You can see it's got a largely independent interface, but it's only about 50% complete. The interface, I mean, because basically I know how to do that now. It's just time consuming, adding all the different variables to it, and running out of room a little bit as well. So here we go, and then just start that off. That's with 800 blobs, and it's still not taxing the CPU too much. You start to notice it if you speed up the simulation, because full speed isn't quite as fast. There may be some scope for some optimizations. So it's not very optimized at the moment, because it's still under heavy development. Now, just to get into the programming a little bit for a moment. So it's mostly in two large source code files. I don't know if that's the preferred way of doing this sort of thing, but we look in this. This has got most of the logic for the simulation and for the rendering. So each blob that you see moving about, just like in the game engine, it's its own object within the game with its own variables here. And then further down it's got the movement code and the rendering code and the code that handles the infections and things like that. So the behavior scripts, in other words. That's all. And as I say, each thing moving about is its own little object with its own variables, its own rules of behavior. So let's... oh, I've started a second one now, I didn't mean to. Let's go back to the first one again. Okay, let's try putting all of those on. Well, let's see. There we go. So that's just them all moving about as much as they want. So that will, rather than having a flattened curve, that will have a curve that peaks quite steeply early on. And let's just go through it, and I'll show you some of the extra facilities that I've added. So one of the main ones, one of the most useful ones, just let that play out and it'll stop when it gets to the end. Let's take that, and then we can export all of these data points to the CSV file, because it's storing them all. So we just save that. There we go. And it just imports as data that can go into a spreadsheet. So this takes the pressure off adding too many analytical and graphing features, because all of the data from the program, there's going to be more than that. It does calculate quite a lot of statistics just as a matter of course while it's running, and they can be exported as well. But I only got this going yesterday, so, and again it was interesting, you know, as a little programming exercise. Here we go, and you can see already that starts to look like something. There's just someone walking past there. Anyway, so take that first column, second column, make those the keys to the axes, and then chart type. Am I out of date? But these default chart types just look weird. But that's a more sort of normal one, I would say. There we go. And there, so there's no real need for me to improve the graphing in the program, because obviously you could throw the best tools that you've got, you know, at looking at the statistics, and I'll make it so that you can, yeah, I really needed to make it so that all of this stuff that led to this outcome, all of this stuff is stored in the file as well, you know, just for reference. But yeah, so that's what I've been working on. It's got, you can actually follow an individual blob now while it's moving about, but I've had to remove that from the user interface just because I ran out of room while I'm trying to decide how to do the user interface. So for example, I think these two things can go next to each other, but this is 50% of the reason that I recode it in Java. I mean, apart from the fact I wanted to learn Java. Let's just go in here. You see, obviously there's a certain convenience to having a visual editor like this for the user interface, but I would say that if this column here was small, I could maybe get these in next to each other and have a bit more room. So I think that's most of the things it does so far. You can put the numbers over each blob now, but that's part of the facility just for following individuals. 400 blobs. Let's take it down to 100 blobs and then increase the size. Again, I don't know what I'm going to do in terms of maybe scaling the size of the blobs so you can run it sort of a bit differently. Now, a lot of these cramped scenarios, you see, that's interesting. Just here we had a load of uninfected ones, and they were clustered together like people living in a house together or a family unit or something, so that one of them gets it and then they all get it, and now one of those has died. Yeah, interesting. Yeah. But this will go really fast with only 100 blobs when I go like that and just go straight to the end of the simulation. As before, you can set it to continuous so that it won't end when all of the infections have disappeared. Oh yeah, and of course you can see some of these are white now, so they're mask wearers, and at the moment you've got to go into the code to say what the benefits of wearing a mask are. I'm still a massive advocate, particularly after having run my own little simulations, I'm a massive advocate of mask wearing, and I think that'll be one of the biggest blunders that governments such as the UK government made. But so that's the current status of it, and I think if I can dedicate another week to it, I think I'll have it in a state where I can distribute it, and then other people can have a play around with it, come up with their own scenarios to test out and things like that. I'm going to try and make it so that most of these variables can be saved and recalled, so you can sort of come up with a scenario and then save it. I have a feeling, because I've never done anything like that before, I have a feeling that all of this stuff, maybe I should have started building that in from the beginning. It's maybe going to be a bit difficult now, but I will try and make it so that you've got a drop down, so you can choose from certain fixed scenarios. But yeah, so that's the current status of it, and I think I'm about a week away from being able to get it to a reasonable state of completion so other people can have a go with it. And that's what I've been working on. This is my lockdown project.